In this video you're going to see how 75 grams of walnut ash was successfully successfully extracted its Ormus from it. And just to find out what that Ormus actually was, then I worked out how much magnesium hydroxide would be in 75 grams of walnut ash, and this is the result. There's no Ormus in this now, and I dissolved it in much more water than this. This is just fine a little bit. And so it is showing that, for walnut at least, then what you see with your eye is magnesium hydroxide. Whether or not there was any M state that was in that and entrained in that, I've got no idea. But let's have a quick look at the experimental design and then get down into the experiment itself.
Okay, this is our experimental design flowchart for our ash process for our walnut material. You can use it for any material, any plant type material. This is a basic outline and with a couple of tweaks. So this would be the main line through here. There's a couple of extra bits that I'll explain that we did in this case, just to explore a couple of things. The first step is to carbonize your material, and you'll normally do that in a stainless steel crucible, and just put it on your flame, and just start out at a fairly low temperature. You can possibly dry it out in the oven first and drive all the moisture off first as an extra stage, which I often do. Depends on what material I'm using, and just the lowest heat you can get it on. Now the guide here is that once it dries out, it'll start to smoke, and you don't want to fill your house up with smoke. You just put your exhaust fan on, but you don't want to produce a whole heap of smoke. So you just sort of got it smoking, and you know it's doing something. So it's just a very small amount, and just keep turning it over, and you'll gradually increase the heat. And when it's all looking like it's dry and blackish brown, then you'll take it off the heat and grind it up. Now I'll use a cheap mortar and pestle, so I got $10 from a discount store, and grind it up. If you haven't got a mortar and pestle, then you can use just the back of a sturdy spoon will do it, a stainless steel spoon, or the handle of a stainless steel knife. You can work out ways of grinding that up, and then proceed to ashify those grounds, nice English word there, and gradually bring the temperature up now. So it will smoke again at the start, so you're starting off from around the similar sort of temperature, and just as it tolerates it, you just gradually increase the flame without producing too much smoke, and in the end you'll find that the bottom of the container will start to glow a little bit, and from my metallurgical background you'll be above 600 degrees when that happens, but your ash won't necessarily be at that temperature because it radiates heat pretty quickly, and you've got to transfer the heat from the container to your ash. Anyway, so you keep the heat on it and keep stirring it every 15 minutes to half an hour. It'll take about 8 hours plus. Could be 10 hours, could be 16 hours. It all depends on the material that you're using. I know it's a long drawn out process, but you can do it in steps. You just keep going. You want to see that ash go from a blacky brown down to it'll go a dark grey, and then a medium grey. So about a medium grey you want to get it to at least. If you do keep going with high heat, you can produce it to a white grey, very light grey and off-white, but you're losing a lot of material to get it to that stage. It's very difficult to do in a home setting. So once you're happy with that, then add acetic acid, which is basically distilled white vinegar, which you can get from any department store, and that will convert all the goodies to carbonates forms. And you'll generally add, depends on what you're doing it with, but you'll generally add it a small bit at a time to your ash. Oftentimes it'll fizz. It doesn't fizz with walnut grounds because they tend to have a bit more of an acid base to walnuts, but every plant's different. Add it slow. You never know what's going to happen when you add it. Acetic acid's not a very potent acid as acids go, so it's not going to blow up in your face. Just add it slowly at first. It will bubble quite vigorously sometimes. Just add a little bit, wait for it to settle, add a bit more, wait for it to settle, and when it no longer fizzes, then add enough again to bring it up to about 300 ml, which is kind of like a workable volume in a small container, depending on your container. Next step is that you can simmer that. You can leave this step out, but I like to do it. To simmer it at 100 degrees for an hour or so, or even more if you want. Just watch your levels, and also watch adding cold material to a hot glass if you're doing it in a Pyrex disc, which I've made that mistake before. And I generally do it in an oil bath, so I have a saucepan with oil in it and something on the bottom so the oil's not in direct contact, or the bottom's not direct contact with my Pyrex container, and that just allows it to heat up a little bit quicker. You can use water, you can also use salt to bring the water temperature up a little bit higher before it boils in it, so just add salt to your water bath. And it's just under 100 degrees really. You don't want it to be bubbling vigorously, you just want it to know that you've got it pretty close to 100 degrees C, and to get some more reaction happening. Let it cool, and then normally you would rack it off, throw any solids away, and you proceed with your liquid, and then you would add sodium hydroxide to bring that up to a pH of 10.7, and then do your washing process. Now, in particular for our walnut, I was just wondering about how dark those grounds were, and so I thought, oh look, I'll try and even leach it again. So first of all, I leached them again, mainly because when you're racking you do lose stuff, so I thought, oh, I might add another 300 mils of acid and leach it again. I heated again, went through the whole thing and leached it off and brought it back. So that's sample C here. The grounds, I took them on again and re-ground them, re-fired them, redid the acid, reheated and re-racked, and brought that through as sample B, and brought it to pH 10.7 as well. But when you get to see the graphs, you'll see that we didn't produce much precipitate, so that was the end of that reaction. This one did, somewhere between 25 to 50% of this one, so I combined those together and washed them. And you'll see right down here that I've got, it was washed 3 times and add to 15 litres of water, so 15,000 mil. So the reason for that, if I can, so there's our 3 streams. This was the A sample. So very quick reactions. Once they decide to go, man, did they go. So lucky I was actually onto it, and I was there with my 10% solution as well. I saw it was peaking, I started to use the 10%, and boy did it go. And this was the C sample, which was the leachings. So straight away, this is racked off. What was left still had a little bit of acetic acid there. Add more acetic acid, and we got a second sample C. And that's it. The grounds, reground, refired, etc., etc. And those leachings, I'm getting a bad angle here. Those leachings didn't produce anything. What's that telling me? Well, even though I've pretty much got everything out of those grounds, there was nothing left in it even after regrinding, refiring and so on. Okay, so ignore that. These two were added together as I explained on my diagram and washed 3 times. Now, what we have over here is a little analysis of what is in walnut. So this is the mineral content, just an average mineral content of walnuts in general. You just Google that, look at a couple of reports, and depends what type of walnuts, but what the exact amounts are. And they were quoted 100 grams, so 3/4 of that, we had 75 grams. So in our sample we can expect, saying there, 0.3 grams of potassium in 75 grams, and so on. We've got calcium here, we've got magnesium here, sodium, manganese, iron, copper and zinc. Once you get down here you can see just that. Minuscule, like 0.003 of a gram, that's just like, forget it, it's nothing much at all. And on my right hand column here I've got the hydroxide form, because we're adding sodium hydroxide, and any kind of reaction we're forming an hydroxide of some kind. Then we're looking at 100 plus grams are soluble in 100 mils of water. Now when we go to wash it, we're using way more than 100 mil each time. So we're up around the litre or 3/4 of a litre, so 750 mil, something like that. You know, so it's a quite a significant amount. So we know that any potassium that we've got in our sample is going out with a wash. And the same can be said for calcium. And there is this minute amount really of magnesium, and is, you know, 1/100th of a gram in our sample, or 1/10th of a gram it's going to be. 1/10th of a gram, that's not very much, but it is something. And who knows what it expands out in water. The only problem with it is it's very insoluble in water, which is why you go back to pH 1 and then try to come up to pH 9 at most, and try and exclude that hydroxide from precipitating when you're doing all kinds of Ormus treatments. So I just thought to myself, oh well, look, what is the actual solubility? That's less than 0.001 grams per 100 mil. In fact, that's what it is there, 0.00064, which is per litre is still only, you know, 0.0064 per litre. That's grams of magnesium as a hydroxide that would be soluble in water. So if we dissolve that into that, it shows that we need at least 15 litres of water for that magnesium to dissolve. Now, it's not all magnesium because it's a hydroxide. So if we've got this much magnesium content, then the weight of the hydroxide is a bit more than that. So if we're dissolving it in, I've already done some dissolving just by washing it 3 times. So if I use at least 15 litres of water, perhaps up to 20 litres of water, then we should be good. So we'll see if it affects the amount of precipitate that we have. So long and short of that is that I'm not going to do a 3rd stage or a 2nd stage precipitate. We'll end at the 1st stage. These are all irrelevant for their content, and we'll know that whatever we've got, the what is it. Okay, so in our case, then the 1st stage is to put this in the oven. So we can place this in the oven, dry it out, and that'll, you can almost take this down to like if you're going to burn a cake, just as it's starting to smoke, just keep it in the oven and dry it right out. So we'll do that. Let's try walnuts. There we go, back on direct heat. I've stirred it up a little bit so it didn't cake. And you can see there I've got a, oh, focus that, aluminium shroud, just an old camping trip. Concentrate the heat, make it more even over the outside of the bowl. Alright, so I'll leave it there for about an hour or 2 and see what happens. Walnut nearing completion, sort of like a mid-grey. Nice and grey. White vinegar. Not much effervescence in this one. On vinegar, it's completely clear. It looks a bit dark, but it's just taking on the shadow from the ash.
I hesitate to call it ash because it no longer looks grey, it's gone black. Now it didn't effervesce when I put the vinegar in there, so what I'm thinking is I'll rack that off and set it aside. I may or may not boil it, but I'm thinking on drying the ash out, rinsing it, drying it out, and further heat treating it. See if I can get a reaction. 122A walnut ash precipitate. So we've just taken the pH from 1 up to 10.7, and you can see it has produced something. And it took 29.5 ml of 30% sodium hydroxide to do so with this volume, which is about somewhere between half and a litre, closer to a litre. And it spiked very quickly, 25 ml. Had only gone from 3.3 pH to 5.4, and so the last 4 ml on top of that to 29 was still just in above 6, probably 6.4, but the last half a mil or so, and it spiked all the way, actually overshot by about 0.4, which I had acid on hand, so I was able to pull it back. So it's sitting steady at 10.7. On 22B, walnut ash reclaims, so it's water, and you can see the ash quite clearly is not really that grey. So racking off the solution, I may just test that to see what's in it, and then throw the ash, let's say, into a stainless steel dish and see if I can oxidise that further. Reclaim 122B, we're at 10.3 with 0.1 NaOH. You can see no precipitate in there, so that ends that line. 122C precipitate reclaim of walnut is almost dry. This time I've just got it in a water bath to do real quick. I did find that it was splattering a bit much. You can see a bit of splatter on the stove there. So let's put it in a water bath. That's getting close to dry, and I'll put it on direct heat. 122C, you can just see the last little crescent moon of damp precipitate. You can just see it just fading out now. It's funny how it's sort of a greyer colour, whereas it looks quite black when it's wet. That's why I thought it had gone to completion. Okay, water's starting to bubble now. That's losing that endothermic effect of it drying. Okay, I think that should be good enough to put on direct heat. I'm just worried about it, sort of the moisture exploding out of it again. There we go, back on direct heat. I've stirred it up a little bit so it didn't cake. Aluminium shroud, just an old camping trip. Concentrate the heat more even over the outside of the bowl. So I'll leave it there for about an hour or two and see what happens. Well, after a few hours it doesn't seem to be hugely different in colour. You can see I've got fairly high heat, if you can see the redness in the crucible. So I think I'll pull that off and put it on vinegar for a day or so, and now have precipitated it, and you can see there is some precipitate in there. You can see it's kind of milky, but that's going to yield nowhere near the last, so I dare say whatever was in it was got. There was some resistance. It took about 10.1 ml at 30% solution of sodium hydroxide to get it to this stage. Walnut, stage 1. The reclaims look by eye to be about 50%. In reality, when you check it out from a volume perspective, it's hard to tell in the video, but I think it's more like lucky if it's 25 to 30%. Rack them off and start the wash process. I'll combine them together once I've racked them off. And check the pH. The pH of the solution, the C is 10.4 and A is 10.1. A has been a lot longer. You often find this, the pH will drop back. If you're worried about it, you could keep adjusting that to get the maximum out of it. I'm not going to bother on this occasion, and that's the reason why there's a difference, is A's been sitting a lot longer than C. So I'm going to rack that off. Now racked off and combined, stirred up, and pH is 10.4 on the precipitate. This is the final wash for our walnut. Leftover precipitate. You can see there's still a small amount of wash water above that. On this occasion I'm just going to take that out because I want to measure the pH of that precipitate. So a great way of doing that is to create a wick like this. You can just do out of a kitchen paper towel, and you'll find if you fold it like that, you can just dip the corner of it first of all, because like that, and now it's rapidly soaking up that moisture. It's up to 1.5 inches, 3 odd centimetres up the paper towel already. I don't know if you can pick it up, but it's about that much. I'll swap it around the other way. Do the same thing. And again, we fold it in half and do the same thing like this. That's just my wife working in the kitchen. Just like that. There, job's done. Okay, now I'll be measuring the pH fairly undiluted. Stir. 10.1 now. That's what it's settled out at. So I like to keep it in these smaller storage jars for whatever I might like to do with that in the future. Now if you wanted to convert this to a powder, you would just dry this out, and I'll show that technique in another video, and anneal it. You could also do that, or else if you want to keep this for some other experiment, you will, which is what I will do. Okay, that's it. 24 hours and the end of the first wash. I've just divided into 3 containers, having about 7 litres altogether, and I can't see much precipitate in bottom. It's very difficult to see, it's fairly translucent, so I'll just reserve my judgment, but it looks to me like some of it's dissolved. So anyway, I've got more water running through the filter and the drain here. I'll get everything happening in a production line. So is coming to an end the third wash, amounting to 20 litre or so, and just dividing it equally between 3 and washing it 3 times. Same as washing it in 20 litres to see if any magnesium hydroxide present will dissolve. I can't really see any precipitate in there. It's fairly translucent, but I've just allowing a healthy amount in the bottom there, just so I don't lose anything. And I'll transfer it all to this smaller jar and let it settle and see what we get. So there we have the dregs from each of the 3 containers settling out 20 litres. Looks pretty clear to me, but we'll let it settle overnight and see what happens.